Okay, so this is one of the tutorial example in your tutorial sheet. So the period tau d of the dam linear oscillation for a certain 1 kilogram mass is 0.3 second. If the stiffness of the supporting linear spring is 800 Newton per meter, calculate the damping coefficient. So in this case, we have to calculate C here. So what you are given is the if you consider this system here, you have a spring and you have a damper here, and the mass is attached here. So in this case, the so K is given Newton per meter and C is unknown. Mass is given, which is 1 kilogram, and you are also given the the time period of the damped linear oscillation for certain 1 kilogram is 0.3 second. You are given tau d, which is 0.3 second. If the stiffness is given, calculate the C. So you need to calculate C here. Okay, so in this case, it's a damped free vibration example here. So in this case, we know that this zeta is obviously equal to C divided by 2m omega n. So from here we can calculate C here. So C will become equal to 2m omega n zeta. So this means that to calculate C, we need to know m omega n and zeta here. So now because we already given m, which is 1 kilogram, we are given omega n, which we can calculate. So omega n is just equal to k divided by m under the root. So k is in this case is 800 and this is 1. So omega n is 28.28 radian per second. Now the next thing that we need to know is this zeta here. So to calculate zeta, we will use this time period tau d. Now we know that tau d is equal to 2 pi divided by omega d. So from here you can calculate omega d here, because tau d is given. So omega d will become equal to 2 pi divided by tau d. So omega d will become equal to 2 pi divided by 0.3. So this will become equal to 20.994 radian per second. So again, this is the frequency. So the units is radian per second. Okay, so now we know the equation for this omega d. So omega d is equal to omega n 1 minus zeta square. This is the equation for the omega d. And we know now the omega d here, which is 20.994, and omega n is 28.28, and 1 minus zeta square. Now from this equation, we can calculate zeta, which will become equal to 0.6721. And you can see that this system is underdamped system because zeta is less than 1. So now if you know zeta, you can calculate C now. So C will become equal to 2 times m, which is 1, omega n, which is 28.28, and zeta, which is 0.6721. This means that C become equal to 38.01, and the units of C is Newton second per meter. So this is the this is what you are asked to calculate.